Hello, Algebras, and welcome to your Chapter 1 Lesson 8 notes on creating and solving linear models. Mostly creating, sometimes solving is how we're going to look at these. You know, there's a lot of times that we are asked to create an equation that's based on some sort of real-life scenario. So, let's start with Kendall, who bought 9 boxes of cookies to bring to a party. Good for you, Kendall. Always bring something to a party. Each box contains 12 cookies. Now, wait a minute. I think based on that, we can probably figure out how many total cookies Kendall is bringing, but let's keep reading. She decides to keep 2 boxes at home for herself. Ooh, how many cookies does Kendall bring to the party? Now, let's just start with boxes. Okay, let's start with boxes. Kendall bought 9 boxes of cookies to bring. Each box contains 12 cookies. She decides to keep 2 boxes at home. So what's 9 minus 2 that she's keeping at home? 7 boxes. So 7 boxes times 12 cookies per box is going to equal whatever 7 times 12 is. So should you not know the answer, 84 cookies are coming to that party. Now, if X represents the number of boxes, and we know that Kendall brings a total of 60 cookies to the party, then which equation could be used to find the number of boxes that are brought? Okay, so let's think about this. There are 60 total cookies. All of my multiple choices has 60 total cookies. Okay, 60 total cookies to the party. We know that if X is representing the number of boxes, we know there are 12 cookies in each box. So 12X would need to be present. We also know that Kendra has kept 2 boxes at home, or wants to keep 2 boxes at home. So she is keeping 2 times 12, or 24 cookies out of the mix, right? So we're keeping those 24 cookies, but we're looking at how many total she purchased. So those 24 would have to be added back to the 60 in the first place, and here is your equation that describes that. You had 12 cookies times X number of boxes, and we know that 2 of those boxes containing 12 cookies each was left at home, so that would have to be subtracted from the number of boxes we were having if we're bringing 60 cookies actually to the party. So a nice little, let's think about how that truly applies if we know how many boxes and how many cookies are per box. And then let's think about it if we don't know the number of boxes of cookies that Kendra had. So 2 ways to kind of use that initial knowledge to talk about, well, what does it mean when I don't know the answer to that? What's that mean? That's where the variable represents the number of things I don't know how many I have. All right, let's look at other building of equations. How about John has 4 more nickels than dimes in his pocket for a total of $1.25. 4 more nickels than dimes. Wait a minute. So that would mean if X equals my number of dimes, 4 more than X would be X plus 4, giving me my number of nickels. Now, when it comes to money, change, dollar bills, that type of thing, we need to know what each type is worth. So dimes are worth 0.10 or 10 cents, right? So we're that 10 behind the decimal. And nickels are worth $0.05, 5 cents. So that 5 behind the decimal place, 2 places behind the decimal place. And the reason I put these here is because in order to figure out a total money, I've got to take my X and multiply it by how much a dime is worth. And I've got to take my X plus 4 and multiply it by how much a nickel is worth. So 0.10 times X plus 0.05 times X plus 4. Notice I'm putting that in parentheses because this whole thing is my total number of nickels that I have would equal $1.25. And this time I built this first and then am going back to look at my multiple choices. So another way that you can handle that, build your equation first, then look at our options. Which option matches? Well, the option that matches, that has the 0.05 times the, in parentheses, X plus 4, the only one that has that is right here. Addition is commutative, so it didn't matter which order I added these two things in, as long as I had the 0.10 times X, because X is my number of dimes, right? The number of dimes. Which equation could be used? B. Now in this next part, how many nickels and how many dimes? Well, once I have that equation set up, I could solve that equation, okay? So 0.10x plus, let's distribute as we bring this down. So it'll be 0.05x plus whatever 0.05 times 4 is. So 0.05 times 4 is, oh, right, 20 cents, right? That's an extra 20 cents. So 0.20, and notice I'm keeping it this way. I'll do 0.20, so I can think of dollars and cents as I'm going, because my answer is to have $1.25. Now I'd combine like terms right here. Okay, ignore the x's for 1 second and think about 10 cents plus 5 cents. That's a total of 15 cents, right? So if we think about these decimals, it's a total of 0.15 times x when we add those up. And let's say you couldn't envision that in your head. You have the graphing calculator. So 0.10 plus 0.05 is 0.15. Okay? That's your number in front of x. Bring down your 20 cents over here. Now, let's subtract that 20 from both sides. So we've got 0.15x equals, what's $1.25 minus 20 cents? So $1.25 minus that 20 cents we just had. Oh, right. $1.05. Now, I'll go over here. And I'll just rewrite so we can see that I'm dividing both sides by 0.15. So that cancels out and gives me x all by itself. X, remember, my number of dimes. X, remember, is my number of dimes. So let me take this, part of the reason I had it right there, 1.05, and divide it by 0.15 to get a whole number of dimes. Because, yeah, I can't have a part of a dime. 7 dimes. If we had 4 more nickels, how many nickels? Right? So dimes, 7, nickels, 7 plus 4, 11. A total of 18 coins in John's pocket. That was a good one to look at. I think you can probably handle this, so I'm going to pause this and have you try the age question down here. I'm going to read it first, have you pause it. Try setting up the equation yourself and getting the right multiple choice answer. Nikki's sister is 5 years less than twice Nikki's age of N. So Nikki's age is going to represent N. N for Nikki. The sum of Nikki's age and her sister's age is 41. Sum, going to give you a little hint, is addition to get a total. Which equation represents this relationship? My advice would be to build your own equation and then look at the multiple choices. But pause it here, take a sec to see if you can answer this one correctly, and when you unpause, we'll see what the correct answer was. Okay. Give it a try. I'll be right back. Okay. The correct answer was choice B. When you see the words less than, it means we are subtracting, but it's a switch around. So the twice Nikki's age had to come first. So we're twicing N first, then subtracting 7 from it. So I wrote out, to remind myself what Nikki was, I wrote out Nikki's age equals N. Okay, so N equals Nikki's age. And then I could think about, well, twice that is 2N, and 7 years less than that would be minus 7. So 2N minus 7 gives me the sister's age. When you add those two things up, it should equal 41 total as their combined ages. Okay? Good try giving that a try yourself. Let's go on to the next page. And we have a nice little chart up here at the top reminding ourselves some numeric examples of what it means to be consecutive, and then to remind ourselves about what it means to be consecutive even or consecutive odd. So I'll stick with some basics to start. Consecutive integers, they are numbers right in a row. Remember, integers, no decimal or fraction involved. So when it comes to integers, this would be like 1, 2, 3, 4. Those are consecutive integers. That's 4 total consecutive integers right in a row. How would I represent consecutive integers as variables? Well, I always make the first thing a one single variable. But how do I get from this first number to this second number when I'm literally just counting numbers next to each other? Well, each number next to it on a number line is adding 1. So if x is the first number's value, then x plus 1 is the second consecutive integer's value. And if, let's say there's 3, then from that first x, you go 1, 2 to get to the third consecutive integer's value. That's your x value plus 2 more away. And so on and so on. We're usually not asked to represent more than 3 consecutive integers in a row. Now, even numbers are different. Even numbers are 2, 4, 6, 8. How are we getting from one even number to the next? We're adding 2. So from 2 to 4 is 2. From 2 to 6 is 4. From 2 to 8 is 6 away, right? So we're always adding 2 when it comes to even numbers. If x represents your first even number, to get to the next even number right in a row, you actually add 2 this time. And to get to the third even number right in a row, you actually add 4 this time. Everyone gets confused about the odds. Remember, we know what odd numbers are. 1, 3, 5, 7, 9, 11, 13. How far apart are odd numbers? Odd numbers are also 2 apart from each other. So if x represents my first odd number? And my first odd number was 1, right? How do I get from 1 to 3? I add 2. X plus 2 still gets me to my next odd number. As long as the answer for X is odd, if you add 2 each time, you stay odd. So then X plus 4 is the third consecutive odd integer. It seems counterintuitive, but it's totally true. As long as X starts out odd, you need to add 2 to keep odd. So let's try to apply this. Write an equation to represent 2, okay, I need 2 of them, consecutive even integers, such that the sum of the smaller number and twice the greater number is 100. Let's look back at what I did as I read. Write an equation to represent 2, okay? I know I need 2 consecutive even integers. So X equals my first consecutive even int. Int, just abbreviations of what we're looking for. I need another one because I need 2 in a row. So let's look up to our chart. The second consecutive even integer is represented by X plus 2. It's my second, and then I'm going to use what we call ditto marks, which look like quotation marks. They just mean consecutive even integer is exactly what that says as well. So I took notes as I read to make sure I understood this is how I'm representing my first of 2 numbers. This is how I'm representing my second of 2 numbers. The sum means to add them up. The smaller number, okay, who's smaller, X or X plus 2? X is smaller, so here's my X, plus, because we're summing, so we're adding, twice, oh, that's 2 times something. The greater number, well, this entire greater number is X plus 2, so that all goes in parentheses. And the result of this, it is 100. So now this is just a linear equation to solve if I'm asked to. I actually wasn't asked to here, but I'm going to anyway just to show you, to remind you, this X would come down to the next line. 2 times X is 2X, and 2 times 2 is 4. You would combine like terms on the same side of the equal sign. And now, to get 3x alone, you would subtract 4 from each side of the equal sign. And what's 100 minus 4? 96. So to get what x is worth, I would divide both sides by 3. Well, 9 divided by 3 is 3. And 6 divided by 3 is 2. So if x is 32, then my x plus 2, my second consecutive even integer, is 34. If I were asked to solve it, that's how I'd go into it. We weren't asked to solve it, we were just asked to write the equation. So, on number 5, I want you to pause this, and I want you to just write the equation of the sum of 3 consecutive odd integers is 18, less than 5 times the middle number. Woof! Okay, 3 consecutive odd integers. Look up to see our representations and write those out. You got this. Give it a try. Pause it right here. Try to write that equation out, and we will be right back.
Eternity later.
Okay. We just wrote out the equation. So it would have been totally fine to stop right here. I was not asking you to solve it. But what I did was I simplified. I didn't finish solving, but I simplified any like terms on the same side. So this is just the simplified version of what I was asking you to write out. The sum of 3 consecutive odd integers. This is the first consecutive odd integer. This is the second consecutive odd integer. This is the third consecutive odd integer. So sum means add each. So that's why all the pieces are there. It could help to put the parentheses around each, even though you're not distributing anything. There's nothing being multiplied by each of those. It just might help you think about each as its own value. And then the middle number is 5 times it and 18 less than that, so minus 18. Those are equal to each other. I did not ask you to solve it. I just wanted you to represent it. We tried to put the harder ones in the notes so that you can use these notes to do the easier ones on the practice. So please, right now, algebras, go to the 1-8 homework and try to apply this. Now, again, use this chart to remember who's consecutive and how to represent those as variables, and what even and odd really means. Those are two apart from each other. Make sure you use the idea of how much a dime is worth, how much a nickel is worth. Maybe know that a quarter is worth 0.25 of a dollar, right? When you're thinking about that one and working on the homework. If you have any questions, let me know. I will see you soon. Good luck on this. See you next time. Bye, Algebra Crew.